get these terms, how we define it. Kapag nucleophile, siya yung electron rich. Okay? And then pag electrophile, siya yung electron poor. Okay. So later, sa mga chemical reactions, types of chemical reaction, we will be mentioning again these terms, these entities, mga species of an atom, and mas madali niyong maintindihan no, yung mga mechanism of chemical reactions later on if you understand these terms. Kasi we have reactions known as electrophilic addition, meron ding tinatawag na nucleophilic substitution, nucleophilic addition. So, yan. So, please know these terms. Electron-rich ang nucleophile, electron-poor ang electrophile. Okay? Now, regarding this, characteristics ng compounds in a polar reaction, possible na ang isang compound could act both ways. Pwede naman nga ang isang compound, pwede siya nucleophile, pwede din siya electrophile, but never neutral. Iba naman yung ibig sabihin ng neutral. Diba? Kapag neutral kasi, kung pH yung pinag-uusapan, it's in between an acid and base. You've heard about amphoteric, diba? Kung may kag-amphoteric, ang isang compound, it could act either as an acid or as a base, depending on the reaction it is involved. But it is not synonymous to a neutral nga compound. Okay? Hindi po synonyms ang amphoteric at neutral. Kung ang pH is lower than 7, halimbawa, or 7.4, 7.5, that is an acidic pH. But higher than that, nga pH, that is a basic pH. Pero in between siya, kung nasa in between an acid and a basic nga pH, that's the time it's neutral. Okay, so magkaiba yung concept na amphoteric sa neutral. Kung neutral, it's in between acid and base. Hindi siya acid, hindi din siya base, but neutral siya. It's in between. Amphoteric, pwede siya acid, pwede siya base, depende sa acid, depende sa reaction. Just like water. Diba? Water, H2O, or how do we draw it? You have bent shape, diba? Ang molecular geometry ng water. Yung water is a very good example na amphoteric. Okay, amphoteric siya. It may act as a base or as an acid. Depende yan sa chemical reaction. If it is reacted halimbawa to an acid, then water will act as a base. If it will be reacted to a base nga substance, then water will act as an acid. So nakadepende yon kung sino yung ka-interact niya sa chemical reaction. That makes it amphoteric. That's why having this nature ng water, pwede siya nucleophile, pwede din siya electrophile. When does it act as an electrophile? Ang water, it will act as an electrophile if it is able to donate proton. Okay? If it is able to donate proton. Kasi 'di ba sabi natin dito sa definition, electrophile is synonymous to an acid. How do we define an acid? One of its definition based on Bronsted-Lowry nga theory, it is a proton donor. Okay, so having the chemical structure ng water, if it is able to donate a proton in a chemical reaction, then it acts as an electrophile. When does it act as a nucleophile? Nucleophile siya if it donates a pair of electrons. If it donates a pair of electrons. Balik ulit sa definition ng nucleophile. Ang nucleophile is able to donate pair of electrons. The same with the definition being a base. Diba? So kung able siya to donate a proton, I mean an electron, here, a pair of electron, then it acts as nucleophile. So there are compounds that may act as both. Pwede siya electrophile or as a nucleophile. So a good example is water. For mga carbonyl containing na functional group, diba, this is a carbonyl. Yan yung carbonyl ha. For any carbonyl containing na mga functional group, just like ketone, aldehyde, carboxylic acid, diba, yun yung mga halimbawa na may carbonyl sa kanilang functional group. For any carbonyl din na mga containing compound, pwede din sila could act either as electrophile or as nucleophile. Nucleophile. So when will it act as an electrophile? When does it act as nucleophile? As electrophile, it acts as electrophile if the reaction occurs at its positively polarized carbon. Kasi between the two, oxygen is highly electronegative, di ba? Highly electronegative, so it will carry or it will pull more electrons towards itself. Okay, so kung ang reaction happens at its positively polarized carbon, then it acts as electrophile. Okay, so if it reacts at its positively polarized carbon center, polarized carbon atom, then it acts as electrophile. But as a nucleophile, magiging nucleophile siya this time if it reacts at its negatively polarized oxygen atom. Okay, negatively polarized oxygen atom. So dito naman. Okay, so that's how carbonyl compound acts as electrophile or as nucleophile. Okay, so yung takeaway niyo dito is there are compounds that may act both ways. Pwede siya electrophile or nucleophile. As long as that compound is classified as amphoteric, pwede siya acid or base in some instances or electrophile, nucleophile in some instances. Okay? So that's the overview of chemical reactions among organic compounds. So this time, let's talk about chemical reactivity of hydrocarbons. So we'll start with alkanes. Okay? Ang alkanes class, if we recall, ang kanyang functional group is having a single bond between carbon to carbon. But in some other references, it's not considered functional group because this bond, carbon to carbon nga single bond or carbon to hydrogen single bond, this type of bonds are also present among all other organic compounds. Okay, present din yan sa lahat ng mga organic compounds. Lahat ng organic compounds, we could observe a single bond, carbon to carbon, or a single bond, carbon to hydrogen. That's why it is less reactive ng mga compound, ang mga alkanes. Less reactive sila. Kaya we will only be discussing at least two of the types of chemical reactions under alkanes. And one of the most common chemical reactions among alkanes, we call it combustion. Combustion, I know you have encountered this type of reaction, or might be you have done this in the laboratory in one of your laboratory courses in your inorganic or in your preliminary lab sa organic chemistry. Okay, yung combustion class, it's a type of reaction that commonly occurs among hydrocarbons. Hydrocarbons. Purely hydrocarbons lang ang meron sa compound. It could be an alkenes, alkynes, but more commonly, it it occurs among alkanes. Very common siya among alkanes. Okay? And in the reaction sa combustion, it makes use of oxygen in the reactant. Okay, for the combustion to proceed, it uses oxygen in the reactant. It will be reacted to the hydrocarbon nga compounds. Sige, let's recall. 'Di ba yung general formula ng alkanes, it's CnH2n plus 2. So any alkanes, if this is reacted to an oxygen in the reactant side, then that could cause combustion to proceed. Now we have two types of combustion. We have the complete combustion and the other one is incomplete combustion. So uh, when does the combustion classified as complete? When will it be incomplete? It depends on the sufficient supply ng oxygen in the reactant. If the oxygen is enough, no, yung supply ng oxygen, it is enough, may enough supply sa chemical reaction. Sufficient yung supply ng oxygen in the chemical reaction, combustion, then that's a complete type of combustion. And the products are the following: carbon dioxide and water. So a gas and an aqueous solution, a liquid water. So yan yung products kapag complete combustion. All the carbons in the compound are combusted, they are burned. Okay, because enough, sufficient yung supply ng oxygen being reacted to it. But we have another type of combustion. We call it incomplete combustion. When is it incomplete? Kapag insufficient na. Insufficient yung supply ng oxygen in the chemical reaction. Okay, so you will know naman sa assessment what products will be formed kasi sa isang combustion na reaction, i-identify man na sa reactant if enough ba or sufficient ba yung oxygen or insufficient, deficient yung supply ng oxygen. So kapag nilagay dyan sa reaction na insufficient yung supply ng oxygen, then it's an incomplete type of combustion. And the products of incomplete combustion, instead of carbon dioxide, it forms carbon monoxide, a fatal gas. It's a fatal gas. And it forms carbon soot, okay, or carbon compounds or mga soot of carbon. And there is also a byproduct, water. So in replacement of carbon dioxide, you will produce this. Carbon monoxide, a fatal gas, and then yung itim-itim. No, sa products, may mga tira-tirang itim-itim. We call it soot or unburned carbon. Hindi nasunog na mga carbon. Bakit hindi lahat ng carbon combusted or burned sa chemical reaction? Kasi insufficient yung supply of oxygen in the chemical reaction. Okay? So any alkanes, any hydrocarbons, halimbawa octane, hexane, pentane, and heptane, mga alkanes na you you know, no, pwede sila mag-undergo og combustion. Okay? Sige. So that's the first type of chemical reaction among hydrocarbons. And again, yan yung predominant, pinaka-common, common good nga reaction among alkanes. The other one is uh, rarely siya ma-observe, rarely observed nga type of reaction among alkanes. We call it halogenation. Halogen, no, from the word halogen. So meaning to say, what is being reacted sa alkanes, so this is an alkane, being reacted sa kanya are halogen. And halogen is a diatomic, diba, na atom. They occur as diatoms in nature, in the environment. The most common nga halogens that that are being used during halogenation is chlorine gas, also bromine gas. But based on reactivity, chlorine gas is more reactive than bromine gas. Okay? Now, for alkanes, ang halogenation nga reaction, it occurs via free radical substitution. Free radical substitution. Okay, so that's the mechanism how halogenation among alkanes proceeds. Okay. If you define a free radical nga atom, ang free radical class, it's a highly reactive, no? Highly reactive nga species. Highly reactive na species of an atom. Bakit siya highly reactive? Because the atom has an unpaired electron. Meron siyang unpaired electron. Halimbawa, kapag ang chlorine, meron siyang unpaired electron, for it to become stable, yung free radical na to, for it to become stable, dapat it will be very reactive enough para ma-attain niya yung stability niya. Okay? Kasi wala siyang partner. Diba? Dapat sa isang stable nga atom, all their surrounding electrons should have pairs. They should exist in pairs. No, yung mga electrons surrounding it. So, ang mga free radical, any free radical ng mga species, they are highly reactive again because they contain unpaired electron. Okay? So, yan yung, kumbaga, nature na ng isang free radical. So, that's how halogenation happens kapag alkane. Sige, let's discuss how technically, halogenation happens via free radical substitution. So in the chemical reaction, we'll need a halogen. So you have an alkane, a halogen is being reacted to it. So let's say that halogen is chlorine gas. Okay, so yung nakalagay dyan, X2, that is simply a symbol, diba? That represents a halogen. Kapag capital X, ano na yan? Halogen yan. So it could be a chlorine gas or bromine gas. Okay? And then, in the chemical reaction, for it to proceed, kailangan merong presence of a UV light or in an elevated high temperature. Elevated temperature, high enough na temperature. What's the use of this UV light or elevated temperature? Kailangan yan in the chemical reaction para yung bond that connects the halogen, itong bond na to, that connects the halogen will break, no? It will cause breakage actually sa bonds that connects halogen molecules. Kailangan niyang i-break para substitution of a free radical happens. Halimbawa, itong chlorine gas, but that's Cl2. So kung imo na siyang isulat, that's how it is represented, yung dalawang chlorine. Kailangan itong i-break prior to substituting a halogen to alkane. How will you substitute something if hindi natin siya i-break yung bond that connects halogen with one another, di ba? So after you break that with the use of a UV light or a high temperature, elevated temperature, you will now form free radicals. That's a free radical of a halogen. So this free radical will be substituted lang, simply substituted to one of the hydrogens meron sa alkane. So halimbawa, ito yung hydrogen attached to the terminal carbon ng alkane. That will simply be substituted with a halogen. Okay, substitute mo yung halogen. Where will that hydrogen, uh, uh, saan na siya mapupunta? No? It will form a byproduct. Ito na yon. Yung hydrogen, nag-substitutan ni chlorine, a free radical, it will now form a byproduct together with the other nga halogen. Kasi 'di ba that's an X2. Yung isang halogen lang of course, yung masasubstitute. O saan mapupunta yung isa? It will form a byproduct. Kasama niya yung isang hydrogen na ni-replace ng isang halogen in an alkane. Okay? So generally speaking, ang mabubuo na product upon halogenation of alkane is an alkyl halide. This is an alkyl halide. This is one of a type na functional group. Isang alkane na may halogen. Alkyl halide or haloalkane. Diba? Isa yung type na functional group. So yan yung mabubuo na product kapag halogenation. Let's say for example, let's have ethane. Ethane is CH3, CH3. So yan ay isang alkane. And let's say it is being reacted to a halogen. The halogen specifically is chlorine gas. For the halogenation to proceed, a UV light or an elevated temperature is required here. Para saan yung UV light and elevated temperature? Simply to break the bond that connects halogen, that connects the chlorine, the diatomic chlorine. Okay? Para makapag-produce tayo ng free radical out of this halogen. Okay? So, ang mangyayari class, the substitution will happen to the terminal carbon. Okay? Hanapin niyo lang yung terminal. Dulong carbon, it's up to you. Dulong carbon on the left, dulong carbon on the right. You replace one of its hydrogen with the halogen reacted to it. So, mahimo siya, CH3CH2, ang isa ka hydrogen diha ni ethane, nahimo nag chlorine. Okay? Asa na padulong ang isa ka hydrogen nga gipulihan ni chlorine? It's a byproduct. Okay, it's a byproduct. Kasama niya doon yung isa pang halogen. Okay? So this is the byproduct and this is the major product. And again, the major product is an alkyl halide. Isang alkane na merong halogen. Can you follow the halogenation process of alkanes? Can we show a thumbs up if you follow the halogenation process? Okay. How about the others? Sige. Hanapin niyo lang ha yung terminal carbon. Terminal carbon ng alkanes. Left or right ba yan? Basta sa terminal carbon kayo. Hanap. Then, one of its hydrogen, you replaced halogen. Kung anong klaseng halogen being reacted to it. Kung chlorine, then chloro ang ilagay mo. Kung bromine, then bromo ang ilagay mo. Then that's it. You will now produce an alkyl halide. Then, ilagay nyo lang yung byproduct. Yung hydrogen na gi-displace natin or gipulihan nato og chloro. Then, ito yung isa pang halogen mula sa reactant. Okay? Sige. So that's all for reactions ng alkanes. Combustion, and the other one, halogenation. Sige, let's have reactions of alkenes. Okay. Okay, class. Now, with regards to alkenes reaction, medyo marami, no? We have different types of reactions that alkenes undergoes. Kasi between the two, between alkanes versus alkenes, more reactive talaga ang mga alkenes. So, kung more reactive siya compared to alkanes, then there will be more reactions na pwedeng ma-proceed kay alkenes. Sige, let's recall the functional group. Meron ang alkenes. Diba yung alkenes functional group, it's double bond between carbon to carbon. And having this functional group, meron siya. It contains a sigma bond and a pi bond. Diba sa multiple bonds, always nga ang main bond dyan is a sigma bond that is formed by a end-to-end collision. Yung pangalawa or pangatlong bonds dyan, considered na yun as pi bonds. And it contains pi electrons. Okay, same with sa alkynes. No? Sa alkynes, di ba, triple bond between carbon to carbon. Palagi, yung pinakaunang bond dyan is a sigma bond. So yung remaining two, dalawa dyan are pi bonds. Now, talking about pi bonds sa mga multiple bonds, no, they, it's their nature na nga weaker yung bond na yan. If it is a weaker type of bond, madali lang siyang ma-break. Okay? So, for any alkenes at saka alkynes nga compounds, for their chemical reaction to proceed, kailangang ma-break yung weaker bonds, ma-break yung pi bonds, meron sila for the chemical reaction to proceed. Okay? Another characteristic meron ang mga alkenes. Because of the presence of multiple bonds, and syempre sa isang bond, 'di ba, that contains electrons. In fact, sa isang bond, it contains 2 electrons. So, paano na lang kapag double bond yan? Kung double bond, how many electrons na yan? 4 electrons. Lalo lang sa triple bond, mas marami. So, that's equivalent to how many? 6 electrons in between that carbon to carbon nga bonding. So, kapag may presence ng multiple bonds, that multiple bond tells us na electron-rich yung portion na yan. Okay, electron-rich. Therefore, for any alkenes, we classify its functional group as electron-rich site. Yung portion na yan ba, electron-rich because of multiple bonds. So kung electron-rich ang alkene's functional group, during chemical reaction, it will react to electron poor. It will react to electron poor atoms. And 'di ba we have terms to describe an electron-rich and an electron-poor. Ano nga ulit yung mga electron-poor na mga species? Is it electrophile or nucleophile? Okay, you can use the chat box ha. Electrophile or nucleophile? Ano yung electron-poor na mga atoms? Sige, go. Nawala yung
Nucleophile.
phone ko. Yes? Kapag electron-poor, nucleophile or electrophile? Yan lang yung tanong ko.
Nuclear.
Kapag, bakit halo-halo na yung mga sagot? What's the final answer? Kapag electron-poor atom, what is that? What's your final answer? Electrophile or nucleophile? O halo-halo pa rin. Sige, final
Nuclear.
answer? Nahalo-halo gihapon. Sige, pinaka-final. O, tantawa inyong notes. Sa may inyong gibutang sa inyong notes kanina. Very good. Final na ha. So, kapag electron-poor atoms, mga electrophile. Electrophile sila. Okay, electron-poor siya. Kaya nga, mas attracted, di ba, ang electrophile sa mga negatively charged. Bakit siya na-attract sa negatively charged? Kasi, very poor siya sa electrons. Tama? Mas marami sa kanya positive. Kaya ang mga electrophile na-attract sa mga negatively charged atom. Okay? So, take note that electrophile doon na-attract ang mga alkenes. Nakuha? Alkenes have electron-rich nga functional group. So, saan siya ma-attract ang mga alkenes? Sa electrophile. Kaya ano yung nasa notes nyo? Ang nasa notes na to, type of chemical reaction that alkenes do undergo, electrophilic addition. Meaning it is being reacted or added with electrophile. Okay? So how does electrophilic addition happens? Ito sa i-erase ha. Paano ba siya nangyayari? Electrophilic addition. Okay. So let's say this is any alkene. So general ni siya, di ba nga, kumbaga general formula ng any alkenes. Sabi natin, majority of the reactions ng alkenes is electrophilic addition. How does an electrophile ba being added sa alkenes? Class, kung chemical reactions gani ang topic, ang concept, you go back to the definition ng functional group. 'Di ba? Kung i-define nato ang functional group, it is the part of the molecule where most of the chemical reactions occur. So kung magstorya ta og reactions ng alkenes, tanan niya chemical reactions mahitabo ra gyud diri sa iyang functional group. Definition ulit ng functional group, it is a part of the organic molecule where most of the chemical reactions occur. So kung ang functional group ng alkenes is carbon to carbon double bond, diha ra gyud mahitabo ang iyang chemical reaction. Tanan klase nga electrophilic addition nga reaction, diha ra gyud mahitabo sa iyahang functional group. Paano ba yung addition of electrophile nangyayari. Okay, for the electrophilic addition to occur, a weaker bond should be broken. Okay, kailangang i-break ang weaker bond. Which is weaker ba? Sigma or pi bond? Diba sabi natin, it's the pi bond. So yung pangalawang bond dyan, we need to break that to allow addition. How can we add something if we do not break a particular bond? Diba? So, di na siya maka-allow og entry sa another nga electrophile kung wala tayo i-break bond. Okay? So, we need to break this pi bond. Thus, itong bond na to, holding electrons, will now have unpaired electrons. So, magiging reactive kung baga yung carbon kanina holding a double bond. So, you break that atong i-change yung color. Be. Okay. Again, we need to break that single bond, yung pi bond particularly. So, each carbon will now become reactive. Okay. Para ma-attain ng double bond carbons na yan, yung stability ulit, it will now allow addition of the incoming electrophile. So you will now have, let me change again. So this is the carbon double bond kanina. Ngayon, meron na silang unpaired, di ba nga? One unpaired electron. So yan, that will allow addition now of electrophile. So one electrophile sa kabila, another electrophile on the other hand. So yung magiging concept niyo dito, for the electrophilic addition to happen, i-break muna natin yung pi bond. I-break ha, i-break ang pi bond para each carbon will now facilitate accepting of the incoming electrophile, whatever electrophile is that. Tsaka mo sila maa-add if na-break na natin yung pi bond. Okay, so yan lang po yung mechanism how electrophilic addition of alkenes happen. So we actually have 4 types of electrophilic addition. Okay? And again, ang mechanism ng apat na yun, na electrophilic addition, ito lang po yung concept. Break the pi bond, then pwede na natin i-add yung mga electrophile, incoming electrophile. So let's start with the first type of electrophilic addition. We call it catalytic hydrogenation. If you understand the term hydrogenation, it tells us nga what specific electrophile being added is a hydrogen gas. Tama? Kaya ang sabi man sa pangalan, hydrogenation. So hydrogen is the electrophile being added. And take note, for any hydrogenation to take place, to proceed, it should be it should come along with a catalyst. So dapat may catalyst kaakibat upon adding hydrogen. Ayan, sorry. Okay, that's why ang nakalagay dito, reagents nga kailangan for catalytic hydrogenation is a hydrogen gas with catalyst. So the most common catalyst during catalytic hydrogenation are metal catalysts because these are strong catalysts. It could be with the use of a platinum, palladium, or a nickel catalyst. Again, kapag sinabing catalyst class, yun lang ay mga substances, mga reagents that will facilitate chemical reaction. They will not cause any chemical or any other chemical nga mga reaction that is not part of electrophilic addition, but ang gagawin lang nila is they will speed up the reaction. They will facilitate the reaction para mag-proceed yung reaction. Yan lang yung use ng mga catalyst. Okay, they speeds up the reaction. Now, using this reagent, the electrophile that will be added now to the alkene are 2 electrophiles of proton. Okay, H+. Galing lang sila ha sa hydrogen. So this will be the general reaction. You have an alkene, any alkene. So hanapin nyo yung double bond. Meron ang alkene. Dun mangyayari mismo yung hydrogenation. Paano ulit yung electrophilic addition? Break first the pi bond. So i-erase na ninyo ang ikaduha nga bond, which is the pi bond because that's a weaker bond. That makes now each of the double bond carbon highly reactive. That will allow them to accept the incoming electrophile. Okay? So, naging single bond na. Then, na-add na ngayon yung hydrogen, yung dalawang H+, galing sa hydrogen gas. And this is not an alkene anymore, but an alkane. So, yung product pala, kapag catalytic hydrogenation of alkene, the product is alkane. Sige, let's have an example. Well, this is the simplest example. You have ethylene, or this is also known as ethene, the simplest alkene. So the reaction obviously will happen to the functional group of ethene, the portion na may double bond, carbon to carbon. So break that pi bond, tingnan ha. Break the pi bond, and it will now allow addition of hydrogen for each carbon. So ito na yun. So from ethene, you will produce the product ethane if ethene undergoes catalytic hydrogenation. What's the catalyst? It's the nickel metal. Again, ang catalyst is only used to facilitate the chemical reaction for the reaction to proceed. Okay? It is not added as electrophile. Hindi yan mga electrophile. Okay, magfa-facilitate lang sila. Parang facilitator lang sila para successfully happened yung reaction. Mo-proceed successfully yung reaction. Now, this type of chemical reaction is the same reaction that is used in the production of margarine. Kasi ang margarine, ang process para makapag-formulate, maka-manufacture ng margarine is also via hydrogenases. They are in liquid form pa kapag unsaturated kasi ang fats, ang fats, liquid pa na siya. So via hydrogenation, catalytic hydrogenation, yung liquid na fixed oil, it will now form saturated na solid fats. That's why ang margarine, di ba, it's solid yung texture niya. Hindi naman siya liquid. Okay, so kapag saturated na siya, saturated, puro single bonds na. Yung nabo, it's now a solid fat. So that forms a margarine. Okay? So that is only an additional information. Okay, this is another example under catalytic hydrogenation. Tingnan ha. From the uh, alkene compound, that is 2,4, this is 2-hexene. Okay, 2-hexene. You start here, numbering 3, 4, 5, 6. So that is simply 2-hexene. And yung 2-hexene daw, it is being processed via hydrogenation. Catalytic hydrogenation. It is being reacted to a hydrogen gas in the presence of a nickel catalyst. So the type of chemical reaction dito is obviously catalytic hydrogenation. Tingnan nyo lang ano yung being reacted sa alkene. If it is an H2, a hydrogen gas, then automatic, that's catalytic hydrogenation. Where will the reaction occur? Hanapin nyo kung nasaan yung double bond. Sa mismong functional group, dun mangyayari yung chemical reaction. Okay? So you have a double bond here. Para mag-proceed yung addition of hydrogen in that portion ng alkene, you have to break the pi bond. Break the pi bond, So each of this carbon will now become reactive. They will facilitate, or they will now accept the incoming hydrogen electrophile. So isang dagdagan mo dito ng isang hydrogen, dagdagan mo din dito ng isa pang hydrogen. Okay, that's why tingnan niyo yung highlighted portion naging CH2, CH2, single bond na. Kasi 'di ba we break initially the pi bond. Can you show a thumbs up if you understand catalytic hydrogenation? Okay. Sige. Then ganun lang din. Very easier if the given is skeletal. Kasi 'di ba kapag skeletal formula, imaginary ang hydrogen. So you don't need to write hydrogens na being added as electrophile in this portion. Yung gagawin niyo lang is you simply omit, break the pi bond. Meaning i-erase niyo lang. Omit, delete the second bond, yung pi bond. Yun na yun. Yun na yung alkane nga product. 'Di ba? Kasi we don't need to write nga, okay, nag-add tayo dito ng hydrogen, nag-add din tayo dito ng hydrogen. Kasi skeletal man. Sabi natin kapag skeletal formula, imaginary, 'di ba, ang mga hydrogen. So you don't need to write the added hydrogen electrophile. Kasi by omitting or breaking the pi bond here, automatic ang nangyari na dito sa isang skeletal formula, may mga imaginary hydrogens na yan being added. Okay? So kapag you encounter catalytic hydrogenation na skeletal formula yung binigay ng alkenes, i-erase nyo lang yung double bond. Yung mismong pi bond rather, yung pi bond. Okay? Sige. Sige, for this example, I will try to answer at least yung number 3. Then kayo na yung mag-answer sa remaining ng mga problems during your independent time study. Pero meron kayong practice problems. Sige, let's have number 3. Again, these are all catalytic hydrogenation reaction. Kasi tingnan yung reaction with H2, with hydrogen gas, hydrogen gas, hydrogen gas. And may mga catalyst, metal catalyst. So all of these are catalytic hydrogenation. Tama? So you complete the reaction. Sabi dito, this alkene is added with H2 or hydrogen gas in the presence of nickel catalyst. Okay? So kopyahin niyo yung buong structure. Yung hindi magbabago, of course, is yung walang double bond. Okay? So yung portion na yan, dyan mangyayari yung chemical reaction na, yung catalytic hydrogenation. So initially, tingnan ha, initially it has double bond in it. Kopyahin ko muna. Yung product, what will happen to the product? Diba? We need to break the pi bond. So one bond na lang. Tama? And then what are the electrophiles being added for each carbon? For each carbon, it's hydrogen. So dagdagan mo dito ng isang hydrogen, so this becomes H2. Tama? Then dito, magdagdag ka rin ng isang hydrogen, so this becomes H3. So that's how you write the product. Break the pi bond, and tsaka na yung addition of whatever electrophile being added. If it is hydrogenation, tig-isa sila ng hydrogen, tig-isa ng hydrogen. Okay? For number 1, dito mangyayari yung hydrogenation. For number 2, skeletal man yan, so simply erase the pi bond. So automatic na yan. Kapag na-delete mo yung, na-erase mo na yung pi bond, may mga imaginary hydrogen na yan being added. Lalo na dito sa number 4. Can I proceed? Can you show a thumbs up if okay na yung sa catalytic hydrogenation? Okay, that's good. Sige, let's proceed to halogenation. Class sa halogenation, almost same lang with the type of halogenation na discuss kanina. Halogenation, obviously, the reagents nga kailangan is halogen. Diba? Yung mismong pangalan ng reaction is a hint already. It's a clue for you to analyze ano yung reagent being added sa reaction. So halogenation, halogens are being added to alkene. And ano yung electrophile that could be obtained upon halogenation? It depends if chlorine ang used na halogen, it's chlorination, then it's the chloro that will serve as the electrophile. If it is bromination, then it's a bromo being added. Okay? So this will be the general reaction. Class, there are two ways paano yung halogenation ng alkenes happen. Depende kung ang halogenation happens using an inert solvent na chloroform, dichloromethane, or a carbon tetrachloride. If you saw this sa chemical reaction na halogenation, always ang product is vicinal dihalide. So paano ba yan? Okay, example sa chemical reaction. Any alkenes, nireact siya with halogen. Okay, kahit anong halogen yan. Mapa-chlorine gas or bromine. Sorry. Tapos nakita nyo sa arrow, sa reactant side, na may inert solvent used nga chloroform. Chloroform is CHCl3. That's 3. CHCl3. Or ang inert solvent na ginamit is dichloromethane or carbon tetrachloride. Either of these three na inert solvent class. Kasama siya upon chlorination or bromination, ang product is vicinal dihalide. So, kumbaga, yung dalawang halogen, it is added individually sa double bond carbon. So, meaning, after we break the pi bond, palagi kapag addition, electrophilic addition, mag-break sa gid ta og bond. Break the pi bond, so each carbon will now become highly reactive. Kung halogenation nga ang present nga inert solvent kay kani either aning tulo, okay? Then vicinal dihalide ang atong product. Naa kay i-add nga halogen sa kabila, meron din halogen sa kabila. Kaya vicinal dihalide, magkatabi yung dalawang halogen. Nakuha? So again, yan yung product if ang halogenation occurs in the presence of these inert solvent. Meron tayong isa pang halogenation process. Paano kapag ang halogenation after adding chlorine gas or bromine gas, ang inert solvent na ginamit is water? Iba naman yung product. Water will facilitate also, will be part of the chemical reaction. Ang product natin is, we call it halohydrin. Bakit? Kasi after we break the pi bond, one of the carbon, yung reactive carbon, will be added with the halogen. Pero yung isang reactive carbon, it will be added with an OH, which is galing sa water. Kaya ang tawag halohydrin. Okay, so just take note of these two types ng solvent na pwedeng gamitin upon halogenation ng alkene. Kung pagtingin nyo sa reaction, okay, halogenation, tapos may kasama siyang carbon tetrachloride or chloroform or dichloromethane, automatic, dalawang halogen yung i-add mo upon breaking the pi bond. So, vicinal dihalide yun. Pero nagkataon na upon halogenation, water yung ginamit na solvent, then halohydrin yung product. isang carbon dyan mula sa reactive site ng alkene, added siya with halogen, yung isa naman is OH. Okay? Sige, this is a good example. Again, the simplest alkene is ethene. Okay? So the chemical reaction again happens here. Based on this reaction, this is halogenation. Halogenation kasi what is being added is a chlorine gas. And sabi natin kanina kapag halogenation, di ba, pwedeng dalawang klaseng solvent ang gamitin during halogenation. So pagtingin natin dito, yung solvent, inert solvent na ginamit, inert meaning it is chemically inactive, no? Hindi siya nagko-cause ng alteration sa chemical reaction. So yung inert solvent na ginamit dito is carbon tetrachloride. Carbon tetrachloride. So ano kaya yung magiging product kapag carbon tetrachloride yung inert solvent? Di ba? It should be vicinal dihalide. Dapat after we break the pi bond, each of this carbon will be added with, okay, halogens. Tig-iisa sila. Chlorine man yung being added. So tig-iisa sila. Chloro, isa din, chloro. So you have a product na vicinal dihalide in this example. However, dito sa halimbawa na to, yung ethene this time undergoes halogenation but in the presence of what solvent? Water. So yung inert solvent dito is water. Ano sabi natin kapag in the presence of water, yung halogenation will form halohydrin. Halohydrin. After we break the pi bond, one carbon dito na highly reactive, it will be added with a chloro. The other one, nga carbon, it will be added with an OH. Saan galing yung OH na yan? Mula dito sa water. That's why halohydrin. Okay? Now, with regards to the attachment of the OH, this will be attached, okay, attached to the carbon with more substituents. Okay, sige, later. You will realize later on, no? If after we discuss the next na type of electrophilic addition, saan mapupunta yung OH. Kasi we actually have an empirical rule to predict the product, the correct attachment of this electrophile if it involves an OH, a hydrogen, or a halogen. Okay, so for now, just know this nga, kapag in the presence of water as inert solvent ang present, no, sa halogenation, halohydrin. If in the presence of carbon tetrachloride or chloroform or dichloromethane, it will form, ayan, vicinal dihalide. Okay, vicinal dihalide meaning tagsa sila og chloro. Kung halohydrin, isa ra, ka-halogen ang added, then ang sa isa, OH. Okay? Pero yung attachment ni OH at saka ni chloro dito, i-discuss natin sa next nga type of reaction. Asa kaha mapadulong ang OH, asa ang chloro. So for now, just know nga, ang attachment sa OH is at the carbon with more substituent. Sige. Okay, let's have this example. All of the given are halogenation type of reaction. Take note ha, halogenation type of reaction. Tingnan yung mga example. Ang lahat ng alkenes na nasa left added with chlorine gas, bromine gas, chlorine gas, chlorine gas. So halogenation yan. Okay? But halogenation occurs in two manners. Pwedeng in the presence of this inert solvent or a water nga inert solvent. Pag carbon tetrachloride, what's the product? Vicinal dihalide. If it is water, halo, hydrin yung product. Okay. Let's have at least yung number 1 and 2. Okay? So yung number 1 and 2, sige, let's have number 1. Yung number 1 dito, atong i-highlight ang reactive site. Asa ba mahitabo ang reaction? Doon mismo sa double bond. Okay? So after you highlight the reactive site, you proceed with breaking the pi bond. Kasi bago natin ma-add yung incoming electrophile, kailangan muna nating i-break itong pi bond. So you break that pi bond so that each carbon will now become reactive. Okay? Tingnan yung inert solvent used upon halogenation sa carbon tetrachloride. So vicinal dihalide yung product. Each of this carbon will be added with a chloro. Tama? So ang mahitabo, you have CH3, CH2, CH2. Kopya ha. Then, itong color red, di ba, ito yung mga reactive site. CH, then blue ulit, CH3. So, akong gi-highlight, no, para hindi kayo malito, asan yung portion na nahitabo ang reaction. Okay? Sige. So, you have here this reactive site. We break the pi bond, so one bond na lang. And if it is a vicinal dihalide, mag-add ta tig-isa. Chloro. Tig-isa chloro. Bakit chloro yung inad ko? Kasi chlorination man. Chlorination yung given na reaction. Okay? So that's it. Then let's have number 2. Bromination naman. Bromination kasi bromine yung added. So highlight nyo yung portion na reactive. I-break ang pi bond. Break the pi bond, so each of this carbon will be added with halogen. Isa will be added with halogen, yung isa naman OH kasi halo hydrin dapat yung product. It will depend man what inert solvent is used. Okay? So it's up to you. Saan dyan yung, di ba, ito yung portion na highly reactive. So after you break the pi bond, isa dyan will have the bromo, then the other one, an OH. Okay, in this given example, pwedeng magkapalit. Pwedeng sa, on the other side, yung OH, on the other side, yung bromo. Sige. We'll have more example later para you'll understand when will be, if there's a choice of selection na ba, asa na to ibutang ang OH, that's under Markovnikov's rule. Nasa inyong notes naman. Okay, sige, for number 3 and 4, you can answer this during your independent time study. All you need to highlight are those portions nga merong double bond. Kopyahin nyo yung buong structure. Ang meron lang pagbabago na mangyayari is doon sa reactive area. Kasi doon mangyayari yung chemical reaction. Kopyahin nyo yung buong alkene, then naalang dayo yung changes dito. If it is halogenation, then you add the chloro. Okay? If it is hydrogenation, you add the hydrogens. Okay, let's have the third type of electrophilic addition. We call it hydrohalogenation. From the term itself, halogenation, the reagents that are being added to alkene is a hydrogen and a halogen. That's why sa reagent nakalagay dyan HX. It could be in a form of hydrogen chloride or hydrogen bromide. You have a hydrogen and a halogen. Hydrogen, halogen. So sila yung pinaka-common nga reagent during hydrohalogenation, hydrogen bromide or hydrogen chloride. So yung electrophile that will be added to the reactive site ng alkene is an H plus and a Cl or a Br, a chloro or a bromo, aside from H plus. Okay, so here's the general reaction if it is hydrohalogenation. So you have any alkenes class on its reactive site sa kanyang double bond carbon to carbon, break first the pi bond. Okay? Yan palagi yung initial step. Break the pi bond so that each carbon will become reactive. So ano yung mga electrophile na maa-add in that reactive carbon? One is an H plus, the other one is the halogen. That makes it hydrohalogenation. Okay? Now with regards to the product, how do we predict the product of hydrohalogenation? Where should hydrogen be attached? Saan naman yung halogen be attached nga double bond carbon? We follow this rule, Markovnikov's rule. This will help us predict the outcome in this type of addition reaction. Markovnikov's rule, this was formulated by a Russian chemist, si Vladimir Markovnikovs. Okay? Vladimir Markovnikov, yun yung pangalan niya. Siya mismo yung nag-formulate ani nga rule para easier yung pag-predict ng product of addition reaction. So how does this Markovnikov's rule being applied? So, di ba, we have this electrophile for hydrohalogenation. Si hydrogen yung isa naman is yung halogen. Yung tanong ngayon, where will this electrophile be added? The hydrogen class, it will be added to the carbon with greater number of hydrogen substituents. Kung sino yung mas maraming hydrogen substituents na carbon, that is where you will add hydrogen. Then in opposite, kung sino naman yung lesser nga hydrogen, doon natin i-add yung X or yung halogen. Okay? So isipin niyo lang, since may hydrogen nga electrophile, sasama siya doon sa carbon na marami din yung hydrogen, yung kaparehas niya. Okay? So doon mapupunta yung hydrogen. Then yung isa naman, yung halogen, sa carbon na lesser yung hydrogen. Okay, let's have an example. Diba? This is an alkene. Yung portion na may functional group of an alkene is, ayan, being boxed. Okay, for these halogen being added, for the H plus and the Cl nga electrophile to be added in this alkene, we need to break first the pi bond. Okay, so tingnan. Gi-break ang pi bond. So, single bond na lang yung natira. So, each of this carbon holding initially the double bond, they will now become reactive. Kapag naging reactive sila, it will now accept incoming ng mga electrophile. Ang electrophile nga incoming is H plus and the chloro. The hydrogen and the chloro. But the question, asa man nato i-add si hydrogen? Asa nato i-add si chloro? Follow Markovnikov's rule. Lantawa, between the two reactive carbon, kinsa ang mas daghan og hydrogen? Didto nimo i-add ang hydrogen. Okay? Kaya tingnan niyo sa product. Itong CH2 na to, naging CH3. Nagdagdag tayo ng isang hydrogen dito. Kasi between the two, mas marami yung hydrogen sa carbon na ito. So based sa Markovnikov's rule, add the hydrogen to the carbon with greater number of hydrogen substituents. So ito, lesser man, yung nasa left ng carbon lesser, yung hydrogen niya, doon naman mapupunta yung chloro. Okay, so that's all about Markovnikov's rule. Sige, let's have another example. Let's have number 1. The hydrohalogen being added is hydrogen bromide. So you will have hydrogen and the bromide as the electrophile. Bakit positive yung mga charge na nilagay ko? Kasi electrophile are positively charged na pole, di ba? So sila yung electrophile being added dito sa portion ng alkene na highly reactive. Okay. First step again, para ma-add na to ang mga electrophile, i-break na to itong pi bond. Isipin nyo ha, we already break that pi bond. So that is already removed in the system. So itong carbon na to and this carbon, you try to compare sino dyan ang lesser, more hydrogen. Kasi kung nga carbon more hydrogen, doon mapupunta yung electrophile na hydrogen. Okay? So between the two, actually, yung pinaka more or greater hydrogen is this carbon. Okay? Yung carbon na yan. Kasi kung titingnan nyo, kahit wag muna nating i-omit ha, kahit hindi pa natin i-omit yung double bond. This carbon, pwede nyo na i-compare agad which has more hydrogen. Itong carbon na to, color blue, meron na siyang 1, 2, 3, 4 bonds. So meaning, wala siyang hydrogen available. Tama? Ang meron sa kanya, may carbon dito, may carbon, lalo na dito. This is another carbon. So wala na siyang available hydrogen for color blue na highlighted double bond carbon. How about yung color red na double bond carbon? Meron na siyang 1, 2, then 3. Ang ikaapat niya na bond is actually an imaginary hydrogen. So you will now know, no? Or have an idea already saan mapupunta later on yung hydrogen na to upon hydrohalogenation. So that would be on this carbon. Tama? So we need first to break the pi bond. Break the pi bond and you can now add the H and the bromo. So kopyahin niyo yung buong structure. So this is a cyclopentane na may methyl dito, may methyl din sa kabila. So ito yung dalawang carbon, di ba kanina? So yung bromo, it will be added here. Okay? Yung hydrogen, automatically, andyan na yan. Skeletal formula man ito. Or if you really wanted to make it visible, pag yun, you can write naman yung hydrogen, dito mo siya inad. Yung bromo, sa kabilang carbon. Pwede din, hindi nyo na ilagay kasi skeletal formula, imaginary ang lahat ng hydrogen in the main parent structure. Okay? So that's it. And then let's have this one, number 2. Number 2, highlight niyo ulit yung portion na highly reactive for an alkene. Ayan. So yung hydrohalogen being added is hydrogen chloride. Hydrogen chloride. Question, asa ka mapadulong ang hydrogen? Asa mapadulong ang chloro? Okay? Sige. First step is we break the pi bond. So i-break niyo yung pi bond and then you compare between these two carbon, asa man ang more hydrogen. O tingnan nyo lang, itong carbon na to, wala man siyang hydrogen. No, wala siyang hydrogen present. Whereas yung carbon na 'to may dalawa. So, diyaan ia-add na carbon yung hydrogen. So, kopyahin niyo lang CH3 and then a carbon, magiging CH3 ito, and then itong carbon na 'to, dun natin ia-add yung chloro. Okay, so you do the same with number 3 and 4. O, tingnan nyo, after you highlight the portion na merong double bond, i-compare nyo na agad sino yung more hydrogen between this carbon and this carbon. Saan ba yung mas marami yung hydrogen? So, dun mapupunta later on yung hydrogen after you break the pi bond. Ganun din. For this, number 4, no? Nga item. Saan dyan? Obviously, very obvious saan mas maraming hydrogen. Doon mapupunta yung hydrogen. And for this carbon, alam niyo na what is being added there after we break the pi bond. Always break the pi bond bago kayo mag-add ng electrophile. Any addition will not proceed if you will not break the pi bond. Okay, talking about hydrohalogenation class. Hydrohalogenation. There are two other cases no, na you might also encounter. Okay. Yung unang case, posible nga yung double bond carbon atoms, they have the same degree of substitution. So, halimbawa, CH3, CH2, CH, double bond, and then CH then CH3. Try to observe the highlighted nga double bond carbon. Let's say yung reaction is hydrobromination. Yung hydrohalogen is hydrogen bromide. Siyempre, kung titingnan nyo dito sa reactive site ng alkene, parehas yung degree of substitution, meron siya. Same ba yung number of hydrogen? So, asa man na to i-add ang hydrogen atom if same sila ng degree of saturation, same degree of substitution? No? If that is the case, guys, the same yung degree of substitution, then you will produce a mixture of addition products. So, pwedeng one product, dito nyo i-add yung hydrogen, sa kabila yung bromo, or the other product naman na mapoproduce, dito i-add yung hydrogen, then sa kabila naman yung bromo. Kasi we have no choice but to produce mixture of products here kasi same degree sila ng substitution. Pareha sila ng number of hydrogen. Walang lamangan, kumbaga. Okay, so one product would be CH3, CH2, then dito yung hydrogen, so magiging CH2. And then single bond, CH bromo, then CH3. Then the other product, pwede naman sa kabila naman yung hydrogen CH3, CH2, then dito yung bromo. Okay, single bond then CH2, CH3. Ito yung reactive site kanina. Try to observe the difference. Diba? So, mixture of products yung mapoproduce. If that is the case, same degree of saturation. You really have to produce all the possible products. The other case naman, letter B, if yung reagents, if reagent nga added is a hydrobromide with an alkyl peroxide. Alkyl peroxide makes use of this general formula ROOR, or usually a hydrogen peroxide alone, no? H2O2. Kapag ang hydrohalogenation with the use of hydrogen bromide is it happens no in the presence of a peroxide, pwedeng any alkyl peroxide or a hydrogen peroxide, then the product will follow anti-Markovnikov's rule. Anti-Markovnikov's rule. Bakit anti? anti-Markovnikovs. Bakit opposite ng Markovnikov's rule? It's because presence of peroxide here, it will counteract the regioselectivity of the um, electrophile being added. Iyang i-counteract ang supposedly selectivity of attachment ng electrophile. Instead of following the Markovnikov's rule, iyang i-counteract. So, anti-Markovnikov's rule. That is mainly because of the presence of the peroxide. Iyang gina-counteract ulit ha, yung regioselectivity ng incoming electrophile. Let's say for example, CH3CH, ayan, CH. So this is 1 propene. Okay, 1 propene. And let's say this undergoes hydrohalogenation in the presence of hydrogen bromide. Tapos may peroxide. Okay, may peroxide, hydrogen peroxide. Class, if you encounter this in the reactants, kapag hydrohalogenation, automatic, anti-Markovnikov's rule iyang i-follow. Asa maad ang hydrogen, asa maad ang bromo, anti-Markovnikov's rule. Kabaliktaran. Instead of adding hydrogen to a carbon with more hydrogen, dun siya sa kabila. Sa carbon nga lesser ang hydrogen kasi anti Markovnikov's rule. So mahitabo CH3 then CH2. Tsaka yung CH2Br. Okay? So yung bromo, this time, na-add siya doon sa carbon na more or greater yung hydrogen. Kabaliktaran ng Markovnikov's rule. Binaliktad lang yung Markovnikov's rule. Again, this case only happens kapag ang hydrohalogenation makes use of this. Hydrobromide, hydrogen bromide in the presence of peroxide. Just like hydrogen peroxide. Okay, yan lang yung clue nyo para sabihin na anti-Markovnikovs na yung magiging product. Okay? So yan lang yung mga conditions that you might encounter under hydrohalogenation. Okay, sige, let's have the last type ng electrophilic addition. We call it hydration. Class, kapag hydration, hydrate. Diba? Kapag sinabing hydrate yourself, what is being added, by the way? Keep hydrated, hydrate yourself. Ano ba yung compound being added sa system? Yes, anybody? Very good. It's water. H2O kapag hydration. So kung hydrogenation, it's hydrogen gas. If it is halogenation, halogen ang being added. If it is hydrohalogen, yung number 3, it's a hydrohalogen being added. Pwedeng hydrogen bromide, hydrogen chloride. So diba, the name itself, the name of the reaction itself will tell you what is being added to the reaction. So kung hydration, it's water. And class, kapag nakarinig kayo ng hydration, it always occur in the presence of an acidic environment. That's why it makes use of an acid catalyst, usually in the presence of sulfuric acid. Any hydration reaction in chemistry, it occurs in acidic environment, kaya palaging may H+. Di ba kapag acidic, acid or proton donor. Okay? So dapat may H+. There should be an availability of an H+, okay, to make the environment acidic. So what's the electrophile being obtained kapag hydration? So mula sa water nga formula, you have an H+ and an OH being added. It also follows Markovnikov's rule, class. The H+, the hydrogen, it will be added to the carbon with more or greater hydrogen substituents. Markovnikov's rule gihapon ha. Follows Markovnikov's rule. Okay, so that's for hydration. Asa padulong ang hydrogen didto sa carbon nga mas marami yung hydrogen. So break the pi bond. Break the pi bond so each carbon will become reactive. Saan mapupunta yung H? Sa carbon na mas marami ang hydrogen, saan mapupunta yung OH? Doon naman sa carbon with lesser hydrogen. This concept is also applicable sa halogenation. Halogenation in the presence of a water solvent. Yung kanina, number 2, yung halohydrin. Paano ba tayo makabuo ng halohydrin? Okay? Yung OH, dun siya mapupunta sa carbon with more substituents. Okay? Or in short, kung more substituent, it has lesser hydrogen in it. Okay? Sige, let's have this example. O, tingnan niyo lahat ng hydration reaction. It occurs in the presence of sulfuric acid. Because sabi natin, ang mga hydration reaction, it must have presence of acid because it occurs in an acidic environment. What are again the electrophile produced from upon hydration? The H plus, and then the other one, the OH. Asa padulong ang hydrogen, Markovnikov's rule, sa carbon with more or greater hydrogen substituents. Okay? Sige, let's have this. Number 1. Hydration. Okay. Tingnan between these two carbon ang more hydrogen. Between the two carbon, itong nasa right side ang more hydrogen. So meaning to say, after we break the pi bond, take note, i-break na to ang pi bond. So mayroon siyang CH3, then CH, then single bond, CH2. After we break the pi bond, we can now add the incoming electrophile. That would be an H and an OH. So, diri na to i-add sa right side yung carbon yung hydrogen. And then sa kabila naman, dito yung OH. So, that will form an alcohol because of the presence of an OH. Okay? Sige, let's have this one. Between these two carbon, ang greater number of hydrogen, obviously, ito, kasi meron siyang imaginary hydrogen in it. Yung kabila, yung nasa taas, wala na siyang available hydrogen. So, automatic, itong hydrogen na to, upon hydration, mapupunta sa bandang nasa baba na carbon. Okay, so when we draw it, okay, kopyahin nyo lahat, CH3, ayan. So, yung OH dito mapupunta in this carbon, then dito naman yung hydrogen. Or it's okay nga hindi nyo na ipakita yung added nga hydrogen kasi nga skeletal formula, imaginary lahat ng hydrogen kapag skeletal formula. Okay? Sige, you do the same sa number 3 and 4. I-compare nyo, saan yung mas maraming hydrogen between the two carbon? Doon mapupunta yung H, then sa kabila naman, OH. So that's all about hydration, class. Okay? Sige. Now for this example, supposedly this is part of practice problem then, I want you to identify the type of reaction among the 4 types. No? 4 types of reaction sinabi natin kanina. Catalytic hydrogenation, halogenation, halogenation, then dehydration. Ano yung unang item? Sige, go. You can make use of the chat box. Just check what is being added. That's the time you can identify what type of reaction. Sige, for number 1, that is, very good, halogen. Okay, basta nakita niyo sa reaction, may hydrogen tapos may halogen. So, combination yan ng halogenation. Whereas, yung number 2, sige, what about number 2? Obviously, this is, okay, catalytic, okay, hydrogenation. Okay, catalytic. Kasi it occurs in the presence of a catalyst. Now, for hydrohalogenation to occur, sige, we need to highlight, no, nasaan ba yung reactive site? So, ayan, yung portion na may double bond. Now, try to highlight yung kulay red na carbon and then color blue nga carbon. Kasi kapag hydrohalogenation, Markovnikov's rule man ang atong gina-follow. Asa between the two, ang meron pang available nga hydrogen, is it the red or blue?
Blue.
Meron pang available nga hydrogen.
Blue.
Red or blue?
Blue.
Okay, very good. Yung kulay blue. Meron pa yung imaginary, isa pang hydrogen in it. But yung yung color red, meron ng 1, 2, 3, 4, complete na yung bonds niya, meron. So, wala na siyang available hydrogen. So, alam niyo na kung saan mapupunta yung bromo, saan i-attach yung hydrogen. So, kopyahin niyo yung buong structure. Kopyahin yung buong structure. And then, ayan. Okay. So, dito na carbon, mapupunta yung bromo. Tama? Then, you can write here hydrogen or pwede na din hindi kasi skeletal formula. Okay, let's have hydrogenation. Highlight niyo ulit yung portion saan ba yung reactive site. Okay, since this is a skeletal formula and hydrogenation is the type of reaction, 'di ba what are being added is yung hydrogen. Kapag skeletal formula, hydrogens are imaginary. So we simply erase the double bond. Then that's it. Yan na yung product. Nakuha? Ato lang i-break ang pi bond. Pero kung gusto gid ninyo ipakita, add niyo mo hydrogen ma'am para sure gid, okay ra gihapon. Okay? Pero since this is skeletal formula, more appropriate na imaginary lang yung mga hydrogen. Okay, so that's how you predict product, identify the type of reaction. Sige, let's have the last types of reaction under under alkenes. So we're done with electrophilic addition. Yung mga alkenes, they are also capable of oxidation type of reaction. So general information muna kapag oxidation class. Kapag oxidation, generally, it's all about addition of oxygen, removal of hydrogen. That's how we understand, no, the concept of oxidation. Addition of oxygen, removal of hydrogen, and oxidation happens in the presence of oxidizing agents. Okay? Kailangan ng oxidizing agents. Okay, in the chemical reaction. So lahat ng chemical reaction that involves oxidation, what are being added sa compound is an oxidizing agent. So we have two types of oxidation reaction that alkenes undergo. We have hydroxylation, or also known as glycol formation, and the other one is oxidative cleavage. Kapag hydroxylation class, the reagent you may use is potassium permanganate, and hydroxylation happens kapag ang alkenes is being added with a cold solution or a diluted, neutralized solution na basic ang environment. Okay? So it should have a basic environment. The environment should be diluted, neutralized, or cold dapat ang environment. So walang application of heat, walang acid property dito for hydroxylation to occur. So the oxidizing agent, it's potassium permanganate. That's the most commonly used one. And the electrophile being obtained out of that reagent is hydroxyl. Kaya nga ang pangalan is hydroxylation. After we break the pi bond, OH, OH are being added. Kaya hydroxylation. So you have potassium permanganate. This is the oxidizing agent. And again, the environment should be basic. Diba? One of the a good example of a strong base is sodium hydroxide. Yung mga OH, hydroxides, basic yon na mga solution and should be in a cold solution. So yan yung kumbaga criteria ng environment for hydroxylation to proceed. In the presence of oxidizing agent, dapat basic, neutral, diluted, or cold yung solution. So ganun lang din, prior to hydroxylation, we need to break the pi bond. So each of the carbon will become reactive. Then isipin nyo, after you break the pi bond, hydroxyls will be added. So that will form the major product, glycol. Kapag vicinal diol, magkatabi yung hydroxyl being added, you form a glycol. Kaya ang tawag din is glycol formation. Now, in the laboratory, if this type of reaction is being performed for alkenes, the visible product in a test tube, visible result is yung formation of a color brown precipitate. That is because of the formation of manganese dioxide. Yan yung visible result na,
Oh,
okay, positive na yung alkenes undergo formation of a glycol. Kapag meron kang nabuo no, sa test tube, at the bottom of the test tube, may nabuong brown precipitate. For this test, we call it Bayer's test for unsaturation. If you will be asked to test if yung sample na yan is unsaturated, di ba, unsaturated kapag merong presence of multiple bond, just like alkenes, di ba? Alkenes, they have double bonds. Alkynes, merong triple bond. So kung gusto na to i-test ang usa ka sample nga unsaturated ba talaga siya, then you can make use of this test. We call it Bayer's test for unsaturation. And the, again, visible result is yung color brown precipitate. Kapag naging brown colored yung precipitate, positive nga unsaturated yung sample. But for any alkanes, single bond, carbon to carbon, wala namang multiple bonds, di ba? Purely saturated talaga ang mga alkanes. If you test it using this Bayer's test, wala kayong makikitang brown precipitate. Okay? Kasi the sample is saturated. Diba? Alkanes are saturated. So this one is a good example ng test. Pwede niyong gamitin to test for unsaturated samples. Okay? Sige, let's have the uh, second nga oxidation type of reaction among alkenes. We have the oxidative cleavage. For oxidative cleavage, exactly opposite ng hydroxylation. So kung kanina, the environment should be basic, it should be cold solution, neutral. Dito naman, for oxidative cleavage to occur, to proceed, dapat upon adding the oxidizing agent, the environment should be acidic. Okay, plus, there should be an application of heat. Yung triangle na yan, that is for the symbol ng application of heat. There should be heat being applied. So again ha, this oxidative cleavage, it occurs when the alkene is treated with a strong oxidizing agent, example, potassium permanganate, and the environment should be acidic, should be hot
so also
environment, and the
one
products
hour.
will now vary. Okay, so these are possible products na pwede nating ma-obtain kapag oxidative cleavage. So you have ulit oxidizing agent, the environment is acidic, kaya na may nakalagay dyan, sulfuric acid, and then application of heat. How do we obtain the product under oxidative cleavage? Okay, you need to understand the nature of the cleaved portion ng alkene. If ever yung, 'di ba, kasi kapag cleavage, kailangan talaga nating hatiin. Okay, hatiin niyo yung buong portion na may double bond. And then you try to assess ano yung nature ng cleaved portion. Let's say, ang cleaved portion is puro hydrogen yung naka-attach sa kanya. Okay, ito yung cleaved portion. Then, that cleaved portion will become carbon dioxide in the product. So, you have to assess ano yung nature ng cleaved portion sa alkene. Para malaman mo kung carbon dioxide ba yan, carboxylic acid ba, or a ketone. This is a ketone ha. It's not an ester. Paki-erase na lang yung isang oxygen. Okay? Sige. If puro R group naman, or yung isa hydrogen, and yung isa organic group, yung cleaved portion, then that's the time it becomes carboxylic acid. Okay? Carboxylic acid. Then you have an R group. Okay? And then, if ang cleaved portion naman is puro R group, yung naka-attach sa kanya, ayan, yung cleaved portion, then that's the time that uh, cause formation of a ketone. Okay? So you have an R group. Diba? That's a ketone. A double bond, carbon double bond O, then R group, R group. So that's a ketone. Okay, let's have an example. Ato sang i-recall. If ang cleaved portion sa carbon na yan, puro hydrogen, hydrogen naka-attach sa kanya, yan, that's the time carbon dioxide yung product. Sa isang portion, cleave portion, kapag ang carbon, meron pa siyang isang hydrogen in it, then ang isa uh, organic group, an R group, then that becomes carboxylic acid. Diba? Ito yung carboxylic. Carbon double bond O, then merong OH. And then, if puro R group naman naka-attach sa cleaved portion ng alkene, that becomes a ketone. Sige, let's have an example. Let's say, the given alkene, let me draw it first. We have carbon, double bond, and then that's the CH3 here. And then, sige, CH3 ulit. CH3. And then dito, CH3. Okay. And then it is reacted to a oxidizing agent in the presence of an acid, so sulfuric acid, tapos heat. So obviously this is oxidative cleavage nga reaction. So how will you predict the product? Paano natin ipe-predict yung product? So hanapin niyo yung reactive portion ng alkene. So that would be the carbon to carbon double bond. So we need to cleave that portion. Kasi cleavage man, oxidative cleavage. So hatiin niyo siya, then tingnan niyo yung nature ng dalawang cleaved portion. I-draw niyo siya. So ito yung unang cleaved portion. Ito yung una ha, cleaved portion. So you have CH3. The other cleaved portion is, baliktarin natin, CH, ito yung other cleaved portion, CH, then
What is that
CH3.
smell?
Class, ingunta, kung kanang cleaved portion nga carbon, puro hydrogen naka-attach sa iya ha, automatic, yung isang product is carbon dioxide. Pero kung napa siya isa ka hydrogen, mahimo siya carboxylic acid. Sige, let's assess. This cleaved portion, you tell me, this carbon, di ba? Wala na siyang hydrogen, puro R group, that is 3. R group, a methyl group, then the other one is also a methyl group. What do you think will be the product for that first cleaved portion? Is it carbon dioxide, carboxylic acid, or a ketone? Sige, very good. It's a ketone. Kasi puro R group ang naka-attach sa iyaha. So, ang mahitabo, kaning cleaved portion niya, it will be oxidized automatically. Dagdagan mo lang siya ng oxygen. So, kopyahin mo yung buo. Sorry. That's CH3, And then this one, CH3, then buo, oxygen. Okay? So this is the first product. It's a ketone. How about the other cleaved product? Tingnan ha, yung other cleaved product, CH, and then, sorry, pwede na to siya ihiwalay. Ayan. Meron daw siyang isang H, and then may CH3. Tama? Yung carbon na to, meron daw isang H. Meron pa isang hydrogen. Tsaka may isang R group. So this becomes carboxylic acid. Okay, how do you produce the carboxylic acid? Yung cleaved portion na yan, that will be oxidized automatically. Yung hydrogen portion, ano yung nangyari sa hydrogen portion niya? It is prone to oxidation then, hydroxylation. So that will form hydroxyl. Okay? So that is now its equivalent carboxylic acid nga product. Okay? Ayan. So you have one OH here. So carboxylic acid na yan. So imo lang i-assess class unsa ang cleaved portion. Kung ang carbon na pa siya H, then carboxylic acid yan. Gawin mong OH yung meron yang available hydrogen. Any hydrogen, it is prone to hydroxylation. Okay, sige, let's have this another example. Yung kahit yung number 1. Actually, yung number 2, ito lang din yun. 2-methyl 2-butene. Yung number 2, ito lang yun. Muning number 2 sa problem. Sige, let's have number 1. Then kayo na yung sa independent study nyo, number 3. Okay. Sige, atong i-cleaved ha. These are all oxidative cleavage nga
Break the
reaction.
bond, tear the
I-cleave
fabric,
na
leave the
to.
stone subtragic. Break the bond, tear the fabric, leave
And
the stone
then you
subtragic. Break
have
the bond, tear the fabric, leave the
first
stone
cleaved
subtragic.
portion, CH3CH, then double bond. So yan yung
Tear
first cleaved portion. The other cleaved portion
the fabric,
is
leave the stone subtragic.
CH2. Obviously, kapag ang carbon, puro hydrogen naka-attach siya, mahimo siya carbon dioxide. So that's the first product. So isulat nyo, carbon dioxide. What will happen to the other cleaved portion? O tingnan, ang other cleaved portion, ang carbon na pa siya hydrogen. Then ang isa, R group. So automatic, mahimo na siya carboxylic acid. Yung hydrogen na yan, mahimo na siya OH. Yung cleaved portion, gawin mo siyang oxidized form. Okay? So ito yun. Yung hydrogen niya, it is prone to oxidation pa rin. Kaya naging hydroxyl. And then you produce the oxidized form from its cleaved portion. So that's a carboxylic acid. Okay, so sulat nyo, that's carbon, double bond O, then hydrogen. Okay, so that's how you predict the product kapag oxidative cleavage. Okay, sige. Ato sang i-keep. Sana may oras. Okay, I think for the topics na alkynes at saka benzene nga compound, I will just provide the recorded lecture video kasi hindi na kaya sa time. It would be exhaustive no sa inyuhang. And if we will continue the discussion, we've been discussing for 2 hours. So maybe I will just give the recorded lecture video. Under alkynes, only 2 types of reaction will be discussed. And the type of reaction, the concept is discussed already kanina. 'Di ba sa alkenes, we discussed catalytic hydrogenation? Same lang gihapon sa concept na yun, yung i-apply under the first step, under the first reaction ng alkyne. So no problem with it. And then for pinakamadaling reactions involves sa benzene. Ako lang i-run through ha. Okay, para meron na kayong idea agad when you, when you study about reactions ng benzene ring. So ayan. With regards to the naming of benzene, na-introduce naman siya under positional isomerism, no? Yung ortho, meta, para position ng di-substituents, dalawang substituents in benzene ring. Ito, regarding sa benzene reaction, the name of the reaction itself will tell you anong klaseng electrophile will be substituted. Halimbawa, kapag sinabing nitration, so you have a benzene ring and then a nitro group is being substituted. Okay, ayan. So that's nitration. Nothing else will be added. Kapag sinabing halogenation, if the halogen being added to benzene is a chloro, then you simply substitute a chloro. So in this example, it's a bromo. So you substitute bromo sa benzene structure, forming bromobenzene. Okay? So actually, yung concept na discuss naman siya. Only that this is talking about benzene ring na. Next, alkyl. Kapag alkylation, it's the R group that is only substituted in the benzene ring. So regarding alkylation, you will be needing an alkyl halide. Okay, that will be the reagent being added, the source of the alkyl group that is being substituted to benzene ring. So yung gagawin nyo lang, tanggalin nyo lang yung chloride group dyan, palitan nyo ng benzene ring. Kaya yung R group lang yung being substituted. Pinalitan lang yung chloro nga portion with a benzene ring. So halimbawa, this one. You have a benzene ring on the left side added with ethyl chloride. Uy, nawala. Ayan. You have an ethyl chloride. And then, to attain the product, inyo lang ning i-omit, no? Tanggalin nyo yung chloro nga portion and then you replace it with a benzene ring. Okay? I-replace mo lang yung benzene ring. Then that's the product. Kunin nyo yung chloro nga portion, replace it with a benzene ring. Then that's the product already. Okay? So you have a carbon containing 3 methyls. Ito na yun, carbon with 3 methyl group. Ganon din dito. This is alkylation. Only the R group ang being added. So tanggalin nyo yung chloro nga portion. Then palitan nyo ng benzene ring. So yan na yun. Same with acylation. Okay? The reagents that you will need is an acyl chloride. Tanggalin nyo lang yung chloro na portion. Tanggalin nyo yung chloro nga portion. So ito lang yung electrophile being added. The acylium group. Halimbawa, in this general reaction, you have an acyl chloride. Tanggalin nyo yung chloro ha. Palitan nyo yan ng benzene ring. That is now the product. So this is a specific example. Ethanoyl chloride. Tingnan ha. Pinalitan lang yung chloro nga portion. Tanggalin niyo yung chloro, kopyahin niyo yan, idikit niyo siya sa benzene ring. Okay? It's up to you saan niyo siya ilagay. Basta tanggalin niyo lang yung chloro nga portion. That's all about acylation. Kasi only the acyl group, itong acyl group is the only portion being substituted sa aromatic ring. Okay? So tanggalin. Palitan nyo to ng benzene ring. So that's it. Ito din. Palitan nyo siya ng benzene ring. So ito na yun. Okay? Then lastly, sulfonation. What is being added nga electrophile is the sulfonium ion. So that is also equivalent to SO3H. Simplified form of sulfonium ion. Isa sulfur, tatlo oxygen, isa hydrogen. And this is the only type of electrophilic aromatic substitution na reversible. Okay, reversible siya na type of reaction. Okay, so hanggang dyan lang yung topic no sa semifinals term for the interest of time. So I discussed it together with the whole sections na kasi I cannot meet the class on Friday and probably tomorrow because tomorrow we will be preparing for the competition which will be held on Friday. We will have an intercollegiate research competition. We have 10 groups representative from College of Pharmacy. So those are fourth year students. So as research coordinator, I need to be with them sa event that would be on Friday, whole day na event. So probably Sir Diobert and Dean Aquino will come with me to witness the event. So that would be on Friday. Whole day na siya. So dili na ako ma-meet akong Friday nga class. So to be fair also with the other sections, di man ako sila ma-fair. Ako na lang yung giusa og discuss lahat para fair sa lahat ng sections nga ma-discuss na ko siya at the same time pacing no for all four sections, lahat ng topics for semifinals term. Okay? Sige, atong i-recap ang topics for semifinals term for examination. That will be from isomerism. Tama ba? So lahat ng isomerism nga topic, alkynes nga naming, and then reactions. Okay, reactions. Yeah. Okay, reactions of alkanes, alkenes, alkynes, and also benzene ring. Kani siya, kaning aromaticity. This is a 3-slide topic man ni siya. Sige. So probably ako lang ihatag. Actually, yung ibibigay ko na recorded lecture video kasama na yung aromaticity. Okay? So it's only a 3-slide nga topic. Isama ko na lang siya doon sa recorded nga lecture video. So try to review also about aromaticity. Okay, but majority of the topic na discuss ko naman, one of the easiest topic man yung aromaticity. You will just identify if the ring is aromatic or not given the following consideration. Sige, what else? So yun lang. So for the semifinals exam, majority of the questions are multiple choice type of question, but you will still expect na may mga portions, just like sa midterm, may portions nga you will be no non-multiple choice siya a question. You will be predicting this time products of chemical reaction. Walang naming probably, pero may predicting of the product. Kayo talaga yung magdodraw ng product. You will identify the type of reaction, then you will also draw the major product. So, majority ng questions about reactions. So, I hope you will study and prepare as early as now no yung mga topics sa semifinals. So, tinapos ko na siya ngayon kay para maka-prepare mo earlier sa inyong mga assessments. Sige, ano pa ba? For Section C, I will be at the office tomorrow. So probably tomorrow na lang nako i-release ang inyong grades. Just prepare 1/4 sheet of paper or 1/8 sheet of paper. Write your name. Then ihatag sa ako Someone will collect na lang from your section para iusaran ninyo og hatag sa ako Okay? Then ang pag-release na ako sa grade, paglinya lang siguro mo. Okay, sa instrumentation room lang siguro para kuan ba siya, confidential manggod siya kay grades man. So dapat ako ra gihapon mo uli sa inyong paper, dili na ako ihatag ang inyong paper sa inyong classmates. So nga na lang agtui lang ko ninyo sa instrumentation room then pag line up lang mo or whatever is more convenient sa inyong available na time. Sige? So I think that would be all for this afternoon. I will not meet anymore section kayong tomorrow, section B. Tama ba? Just make use of the time to study. Prepare for the upcoming examination. Okay, para mas mahaba yung time na inyuhang studyhan ba ang mga topics. Sige. So thank you everyone and God bless. See you next week for your examination. You can take the exam ha with or without permit. Just wear your uniform lang good. Kana lang good. Wear your school uniform during exam. So thank you everyone. God bless.
Bye, ma'am.
Thank
Thank
you,
you.
ma'am.